Alright, in this section we're going to solve some applied problems. We're going to take the skills we learned from the last section, solving right triangles, and just apply them in certain problems that are described. Basically, it's our job to figure out where's the right triangle in this problem and what is it that they want me to find. So usually we don't have to solve the whole right triangle, we just need to know what part they want us to find and then find it. So we'll start off with this one. This says the Goodyear blimp is 600 meters above the ground and south of a football field. The angle of depression from the north goal line from the blimp is 42 degrees. So that's what's shown right here. How far is the observer from the north goal line? So when they ask how far is the observer in the blimp from the north goal line, that means we want to find that distance D. Now there's a couple of ways we can do this. First of all, we could see a right triangle here, right? This is a right angle. If they give us the height, that's a perpendicular measurement to the ground. And so we could use this right triangle. Now we need an angle inside that right triangle. They gave us the angle of depression, and as it happens, the angle of depression that they give us, or the angle of depression in general, is always equal to the angle of elevation from the other viewpoints. So this angle up here, we know that is 42 degrees. Equivalently, we could say, well, this here is a right angle, and so this angle has to add up to 90 degrees with 42 degrees, and then deduce that this has to be 48 degrees. You could use either of those two angles, the 48 degrees or the 42 degrees. So what I'm going to do is I think I'm going to use the 42 degrees here. We want to find the value of D, and we know this measurement. So these bits highlighted in yellow. Now I want to think about what is the trig function I can use that'll make an equation with D and 600 and the angle 42. So if I'm using the angle 42, 600 is opposite and D is the hypotenuse. So that's the sine function. Sine of 42 degrees is equal to 600 over D. Now D is now in the denominator. I want to get it out, so I'm going to multiply by D on both sides. Now we have D times sine of 42 degrees is equal to 600. Sine of 42 degrees is just a number, it's some value. So I'm going to divide both sides by sine of 42 degrees. So D is equal to 600 divided by sine of 42 degrees. And we get 896.69 meters approximately. Now, if you were solving this problem and you look up the answer in the back of the book, they would probably call it 900 meters because they would maybe be rounding it to one significant digit, or even if they were rounding it to two significant digits, it would be 900 meters. Now, I'm not bringing that up to suggest that you should be rounding in that way. It's okay to. I'm more or less bringing it up because if you look up an answer and you're close, but the book seems to have something where it looks like they've rounded in some way, or it looks like it's a bit off, that could just be that they are rounding to some number of significant digits. So you could check how many significant digits did they use in the given measurements. Okay, next. Let's see, we have a horizontal distance, 75 meters, is measured from the base of a vertical cliff, so that's shown right here. The angle of elevation from this distance measures 65 degrees. So like if you're standing here, you would have to sort of lean back your head at an angle of 65 degrees to be looking straight at the top. We want to find the height of the cliff, so we want to find h. So now I think it's pretty clear, where a triangle is. They say it's a vertical cliff, so that's a right angle. I think that's a safe assumption. And we want to set up an equation that uses the angle we know, the side we know, and the side we want. And thinking of SOHCAHTOA, I think it's the tangent part that we'll want to use. TOA tells us that tangent of 65 degrees is equal to h over 75. Opposite over adjacent. We want to solve for h, so we will multiply both sides by 75. And we find that h is equal to 75 times tan of 65 degrees. And we get 160.84 meters. So we don't have to solve the whole triangle, right? We're not solving the whole triangle. We're trying to identify where is the triangle in this problem and what part of the triangle are they asking us to find. And once we do that, then we're done. Okay, one more. One level at an airport is 7.20 meters above the level below. So we have, like, say, a lower level and like first floor, second floor, and that vertical measurement is 7.20 meters. An escalator that is 15 meters long carries passengers between levels. So when they talk about the length of an escalator, and this is true whether, if they're talking about the length of an escalator, if they mention a length of a ramp, they mean the slant length, right? Like the length of the actual escalator itself, not the horizontal distance it spans. What is the angle at which the escalator moves from one level to the other? So we want to find the angle theta here. And we know the hypotenuse, and we know this side here, which is opposite theta, and this is a vertical height, so that's a right triangle. So we found there's our right triangle. We want to find theta. We know those two sides, so think SOHCAHTOA. Think if you can figure out what function we should use. I think that if we use the sine function, that should do the trick. So the SO part of SOHCAHTOA says that sine theta is equal to opposite over hypotenuse, so that's 7.20 divided by 15.0. And if I know the value of sine theta, we get theta by finding arcsine of that fraction. So inverse sine, second sine, 7.2 divided by 15, 28.7 degrees. And that's what they wanted us to find. We don't have to solve the whole triangle. We're just looking for that angle.